Okay, so today the topic that we are going to study, it's basically the continuation of previous topic. In previous class, we were studying kinematics of particle, and we were discussing rectilinear motion. And then in rectilinear, basically we studied rectilinear continuous motion. So today again, the same section, the major section is same, that is kinematics of particles. And in that one we will study again rectilinear motion, but now today we will not study the continuous one. We will study the other section of rectilinear motion, which is rectilinear erratic motion. So definitely the question arises in everyone's mind that what is the difference between rectilinear continuous motion and rectilinear erratic motion. So if you recall your previous class, so we were having rectilinear continuous motion. In that case, to represent any motion, whether it is displacement or whether it is velocity or it is acceleration. So for that purposes, for all those cases, what we used to do, we used to have one equation. For example, this is example from previous class. So we are having just one equation to represent the displacement versus time. So means throughout this instant throughout this time range, the displacement is having just one equation. Similarly, if you look at the velocity curve, in this case, for example, if we take derivative of displacement, so we'll get the velocity. So the velocity for whole range of time means for the total time span that we have, a single velocity equation is used. So such type of motion is basically known as continuous motion. Now, if we consider the acceleration, if we take its derivative, so it will be zero. So for the continuous time range, means for the given time range, we are having one equation that remain continuous for the given time span. Whereas in case of erratic motion, the motion is not continuous. Means for every interval of time, for a given interval of time, we might be having one equation. Then, for example, from 0 to 5 seconds, there might be one type of motion, and then from 5 to 20 seconds we might be having another equation. The type of motion or the equation that the motion basically follows, it may be changed. Then from 20 to 30 seconds we might be having another equation. So in that case, like you see, we are having a continuous graph. We are having continuous graph. So the continuous graph can be like this, it can be like sinusoidal, okay, or it can be a straight line, it can be a curve. But in case of erratic motion, to represent displacement, velocity, or acceleration, we can have more than one equation. Like, for example, you can see equation 1, 2, 3, 4, and so on. Okay. So again, this is like continuous motion equation. So for displacement, we are having this equation. When you plot it, so you get this curve. Okay. Now, in this case, for whole limit of time range from start till the very end, only one equation is used, this one. Now, if we take its derivative, so definitely we will get this one. And when we plot velocity based on this equation, so we get this plot. So again, same equation is used. So we are having again a continuous motion, means one equation is continue for the whole time range. Similarly, when you take derivative of this equation and find out the acceleration, so the same acceleration will remain for the given time span or for given time range. So means again one equation remain continue for the whole time range. So this means the motion in this case can be represented by a single equation, or single equation will remain continue for the given time span. So this is basically displacement curve. Then we are having the velocity time plot, and then we have the acceleration time plot. Okay, now what is basically erratic motion? So when particle has erratic motion, means when particle, the motion of particle cannot be represented by a single equation. Means for every range of time, you must have a different set of equation. So in certain cases, or in such type of cases, when a particle has erratic motion or changing motion, then its position, velocity, and acceleration cannot be described by single continuous mathematical function along the entire path. Means we might be having more than one equation. It can be 2, 3, 4, 5, and so on. So instead of using one continuous equation, what we use, a series of function or a series of equation will be required to specify the motion at different intervals. And for this reason, it is more convenient to represent the motion as a graph rather than to represent it by just a simple equation or by a series of equation. Okay. So if you look at this one, if you look at this curve, now in erratic motion, for example, from this time range from 0 to 10, we are having one type of equation. So if you look at this one, we have this equation. And then from here till this one, again the equation has been changed. And then from here it is changed again. It might be difficult for you to differentiate in this curve, but if you look at the acceleration curve, so for acceleration curve means if you look at the time range from 0 to 10 seconds. So in this case, the path that acceleration follows, it is like this straight line that is moving upward. And then from 10 onwards, from 10 to 20, what we have basically, the acceleration is changed, means the behavior that acceleration shows, it is different. So for this, another equation is required. So this one, you can see, we are having another. And then from 20 to 30, we are having zero acceleration. So in given time range, that is from 0 to 30 seconds, to represent the motion, we are having three different equations, because single equation cannot represent these three different types of motions. So instead of one single equation, we are having here three equation or three functions. समझ आ रही है आप लोगों को? Are you people getting me?
Yes, sir.
Okay. So for erratic motion, if a graph of motion that relates any of the two variables, for example, SV, VA, AT, so means among them, if any two variables are related by a graph, and if we get this one graph, then by using this single graph, we can find out the remaining variables. For example, if we are having displacement versus time graph, so from this we can find out the velocity. And if we are having velocity against time, so from this case, we can find out the acceleration. Similarly, if we are having graph between acceleration and displacement, if we are having graph between velocity and displacement, so in such cases, we can find out the remaining variables. So how we can find out, we will see it. So if we are given the graph, so from this we can find out the position, velocity, and acceleration of particle, and how we can do it by using that single graph. And the graph can be between ST, it can be between VT, AT, VS, and AS. And if any of the diagram is given, so from this one diagram, we can find out the remaining values. How? For example, if we are given the ST curve means displacement versus time plot. So from this, we can find out velocity versus time graph. Okay. So we know that what is velocity? Velocity is basically derivative of displacement with respect to time, right? And we know that, for example, if we are having some XY plot, and if you want to find out the slope of this XY plot, so that is basically dy by dx. So here on the y-axis, we are having s, and on x-axis, we are having t. So the slope of this equation can be identified, can be determined by using ds by dt. ds by dt. So where ds by dt is equal to velocity. So in other words, for example, if I found out, if I try to find out the velocity, the slope of this curve over here for this interval, so from here I can get the value of velocity. So means at this instant, if I find out the slope of this curve, let's say that slope is v naught, or ds by dt at t is equal to 0. So I know that the slope of this curve is equal to velocity. So I got this v naught. That then at another instant, at another point, I again find out the slope of this line. So let it be at time t1. So I have given it the name v1 because the slope is equal to velocity. Then at some instant 2, I found out another slope. So by finding out this, the velocity, the values of slope at different set, at different position, what I can do, I can note down those values, and every slope will be equal to the velocity at that instant. So now I have In other words, if instead of slope, if I use this word velocity, so now I have v naught, I have velocity at instant 1, at instant 2, and instant 3. So when you have all these three value, what we can do, we can plot velocity versus time values. So for example, at instant over here, for example, if the velocity is 0, so it will be here. If the velocity is 10, so it might be here. Then at instant 2, let's say if the velocity is here, so it will be here. So means by joining those points, what we will get some curve. So over here, so some from some hypothetic values, what we get basically, for example, if the initial velocity that we get at v naught, let it be 20, so let it can be 20. Then at second instant, let it be 17, so this can be the second point. I'm using just hypothetical values, means it can be any values, but at least you get the idea that how we can plot the velocity versus time plot if you are having a plot between displacement and time. So means if you are given with st plot, from this you can construct the vt graph. Is it clear to everyone?
Yes, sir.
जी समझ आ रही इस चीज की?
Yes, sir.
Yes,
Okay.
sir.
Now, for example, if you are having a plot between velocity and time, so the slope of this plot, it can be given by dv by dt. And we know that dv by dt is equal to acceleration. So if you find out the slope of this plot at different locations, so that slope is basically equal to acceleration. So this means we are getting acceleration at different instances. So take that acceleration and plot it against time. So we can get this acceleration versus time plot. I hope this is clear because it is similar to the last one. We just need to find out the values of slope, and those will be equal to acceleration. So we can plot those values against time, right?
Yes, sir.
Okay. Now let's do it the other way. For example, if we are having a plot between acceleration and time, if we are having uh, a plot between acceleration and time, so we know that basically that acceleration, if we take integral of acceleration, so we can get velocity, and if we take integral of velocity, we can get displacement. So here, area under the curve, through integral we can get area under the curve. So if I can find out area under the curve between this interval from here till here, and this area under the interval, it will be basically equal to, delta v. If you remember your thermodynamics class, this is your third semester, so you already been through your thermodynamic 1 course, right?
Yes, sir.
Okay, in that we basically have one equation, w is equal to integral pdv. है ऐसा कुछ?
Yes, sir.
And if you are having pv diagram, so area under the curve basically gives us what?
Work done.
Work done. Very good. Okay, so now in this case, velocity is basically equal to integral of acceleration and this dt, right? So if you are having at plot, so area under the curve will gives us what?
Sir,
G.
distance.
Okay,
Distance.
area under the curve will gives us what?
Distance, sir.
Why distance is given already here, I just wrote it. If you take
Velocity, sir.
integral of acceleration, so it will give you velocity. If you take
Yes.
integral of velocity, it will give you the displacement, right?
Yes, sir.
Okay, so means if you know the initial velocity, so you can find out, means from this difference, you can find out the final velocity between that instant. So let's say the initial velocity is, we know the initial velocity, and we find out this delta v, so we can find out the second point on the velocity curve. Now again, area under the curve between any other instant will give you delta v2. So now we already have this point and we have delta v2. So from delta v2 we can find out another point. So by doing so, we can get this velocity diagram from acceleration diagram. right? So from ET diagram, if you are given with AT diagram, you can find out, you can construct a VT diagram. Is it clear?
Yes, sir.
Okay. Similarly, if you are given with velocity time diagram, so from velocity diagram, time diagram, if you are having velocity and if you want to find out displacement, so what you can do, you can integrate this with respect to time. So in other words, area under the curve on VT diagram will gives us displacement. So area under the curve will gives us delta S. So from if you know the initial displacement, you can find out the final displacement within this limit between 0 to T1. Similarly, if you find out the area under the curve between the second interval from T1 to T2, so you can find out the second point, and so on. You can plot this ST diagram, right? Okay, मुझे reply दे दिया करे ताकि मैं आगे move करूं. If you
Yes,
don't
sir.
reply, I
Yes,
will
sir.
assume कि आपको समझ आ रही है. Okay.
समझ गए सर.
Okay. Kindly give me a minute. हेलो, आवाज आ रही है?
Yes, sir.
Yes, sir. Yes.
ओके, सॉरी, असल में मैं डिपार्टमेंट भी यहाँ पे बाजू का कॉल वगैरह आ जाती है. ओके, सो नाउ लेट्स कंसीडर another case. If you are having AS diagram, means acceleration versus displacement. So we can construct the VS diagram from this one. So if you recall this equation, now if you are having acceleration and for example, we are having acceleration. So acceleration can be rewritten as, for example, let's say A is equal to dv by dt, right? So instead of dv by dt, what we can do, we can write it this way: dv by ds into ds by dt. Okay. So this means this one is basically dv by ds. It will remain as it is, and this one will become equal to v. So this means acceleration into acceleration. This equation can be like simplified if we take this v over here. आपको आवाज आ रही थी?
No, sir.
No, sir.
Okay. So from here, this will be ads, and this one will be equal to v. So what we will get? We will get v dv is equal to ads. If you take both side integral, so you will get this equation, right?
अरे इसकी समझ नहीं हुई सर, दोबारा समझ.
अच्छा.
Sir, इस
let me
equation
write
की
it again.
समझ नहीं आई.
Acceleration is equal to dv by dt, right?
Yes, sir.
Acceleration is equal to dv by dt, right?
Yes, sir.
And if I multiply and divide it by ds, so कोई फर्क तो नहीं पड़ेगा ना?
No, sir.
No, sir.
Okay, so I multiply and divide it by ds. Okay, so this ds by dt is equal to velocity,
Velocity.
right? So instead of this one, I will put velocity, and this one will remain as dv by ds. I will move this ds over here, so this one will become ads, and this dv, and we will combine, this one will become vdv. So that's why we have ads and vdv, right?
Yes, sir.
Okay, so when you integrate it, when you take that integral, so from here, when after taking the integral, you will get this equation and this equation, right? So this means over here on the left side, what we have velocity, and on the right side, what we basically have acceleration ds. So means if we are having as diagram, and if we find out the area under the curve on this plot, so what we will get the thing that we have on the left side. So what we have on the left side? Velocity, right?
Yes, sir.
ठीक है. So कहने का मतलब ये है, if you are having as diagram, and if you find out area under the curve, and if we know the initial velocity, so we can find out the final velocity at that instant. Then again at second instant, if we find out the area under the curve, so we can find out velocity at the second instant. So simply what I want to say, if we have as diagram, what we can do, we can integrate it, and we can find out the velocity versus displacement curve from it. Is it clear now?
Yes, sir.
Yes, sir.
Okay, few people might be confused with this thing 1 by 2. So 1 by 2 is constant, right? So means and we also have velocity square on this side. So whether it's square root, whether it's multiplied by a constant, or whether it's raised to power 3 or anything, but at the end, what we will get some value of velocity on the left side. So I'm not saying that the area under the curve in this equation or in the previous equation will be the same, but whatever we have on the left side, in case of this equation, we will get area under the curve, means the thing that we have on the left side. So from area under the curve for this equation, for this plot, we will get this value that we have on the left side. So area under the curve from AS will give us the velocity. Okay. Now, for example, if you are having velocity displacement graph, if you are having velocity displacement graph, and from this, what we can do, we can construct AS diagram or AS graph, that is acceleration displacement curve. So again, in previous case, what we were doing, we were taking integral. Now in this case, the acceleration derivative is 1 time higher than the velocity. So what we can get, if you are having this velocity curve, So what you can do, you can take its derivative. So means derivative is basically equal to the slope of this equation. So means you can find out the slope of equation at different instants. So this one will basically give you acceleration at different instants. So this one will become a naught, this one will become a1, this one will become a2, then a3. So if you plot this one against displacement, what you will get as curve. So in other words, in simple word, if you're having Vs diagram and if you find out slope at different instances, so from this you can plot if you are having Vs diagram and if you find out slope at different instances, so what you can do, you can plot As diagram from this one. And if you are having As diagram, if you want to cross Vs, so what you need to do, you need to take integral at different sections, or you need to find out area under the curve, right?
Yes, sir.
Okay, so the end conclusion is, for example, if you want to go from displacement towards acceleration towards velocity, you need to take derivative. If you want to go from velocity toward displacement, you need to take integral. If you want to go from acceleration towards velocity, you need to take integral. So if you are going towards higher order derivative, what you need to do, for example, from displacement to velocity, you need to take derivative. If you are going from displacement towards acceleration, you need to take double derivative. If you want to find out displacement from acceleration, you need to take double integral. So this is like very basic concept which we have in our initial classes. Okay, so now give me a minute kindly. Okay, so let's have an example. An object travels along straight line path and the initial displacement is basically given, whereas the initial velocity is also given. Both are 0. Its acceleration in meter per second square as a function of time is also given. Construct ST, VT, and AT motion graphs. What we need to do, we need to plot these three things. And we are given three equations. Right? So which equation we should use to find out the velocity, acceleration, and the velocity and displacement? Or which equation should we use for acceleration? Either the first one, second one, or third one? Or do we have to use all these three equations?
Sir, all equation must be.
Okay, all equation must be used because we need to find out the displacement and velocity for this whole time span from 0 to 30, right? So for a complete time range, we don't have one equation. We are having three different equations, means the behavior at different time is different. So what does that mean? What type of motion do we have over here? Erratic motion, right? Okay, so initially means let me plot a graph between acceleration and time. So from 0 to 10 second means from 0 to 10 second, which equation we will use? We will use 0.40. So we will put initial t is equal to 0. So when you put that 0, you will get the value over here. And then we will put t is equal to 0.5, 1, 2, 3, 4, 5, up to 10. So when we do it, what we will get basically, we will get plot like this, right? And then for the second time interval, the means from
सर ये तो ST ग्राफ नहीं हो गया सर, ये तो AT ग्राफ हो गया. आपने एक्सेलरेशन फाइंड कर.
So we are having already acceleration हमारे पास मौजूद है ना, right?
सर आप कह रहे थे कि ST ग्राफ.
Okay, what we have over here in the question construct is ST, VT, and AT motion graphs, right? तीन चीजें फाइंड आउट करनी है.
Yes sir.
Okay, so अगर AT हमारे पास acceleration given है, so let's find out ET first, right?
Okay. Okay.
Okay, and then we will find out VT and ST from there. Okay. So for the second time interval means from 10 to 20 second, that is from 10 to 20 second, the acceleration will remain constant at 2.4, right?
Yes, sir.
Okay, so means if you look at here, the value is 2.4 and it will remain as it is, that is 2.4 till 20 seconds, right? And then from 20 second to 30 second, the acceleration will become 0. So from 20 to 30, you can see it. Okay, give me a second. Okay, so from 20 to 30 second, the value is basically 0. So that's why it's shown like this. So in this case, to represent the acceleration, we are having three different equations. Okay, so this is like an example of erratic motion. Now the question is, AT is done, means we have got that AT graph. Now we need to find out PT and ST graph. So how we can get it? So let's do it this way. So as acceleration is basically equal to dv by dt, right? So this means dv will be equal to a dt, right? If
Yes,
we
sir.
take if we take integral of acceleration, if we take integral of this acceleration, so we will get velocity. So first what we will do, we will use this equation a dt is equal to dv, but for first interval 0 to 10 second, what we will use, instead of acceleration, we will use this 0.4 t value, right?
Yes, sir.
And the time limit will be from 0 to 10,
10.
or let it be t. Okay, so t can be up to 10. So from 0 to t, this is like the time limit. And then on the other side, we are having velocity. So if you look at the question, initial velocity was how much?
0.
0. So final velocity, basically we need to find out velocity at t is equal to 10 seconds, right? So that's why I left it as v. Okay. So when you find out, when you integrate this equation, what you will get this value 0.2 t square. So if you put this limit from 0 to t, so what you will get, basically, if you put t is equal to 0, if you put t is equal to 0, so you will get 0 velocity. If you put t is equal to 1, then 2, then 3, then 4, up to 10. So when you put this equal to 10, so what value you will get? 10 multiplied by 10, it will give you 100, 100 multiplied by 0.2. So what you will get? 20. So this means the velocity will start from 0 and it will go up to 20. And you can see it's t square. So second order, second degree curve we will get. So from 0 it will start, and here is the second value for the velocity at t is equal to 10 seconds. यहाँ तक clear हो गया?
Yes, sir.
Okay. Now let's go for the second time interval. Let's go for second time interval. So now at this, for the time interval 10 to 20 second, the initial time will not be 0 now. The initial time will be 10 second and final time will be t or 20 second, right? Okay. What about initial velocity? अभी initial velocity आपके पास क्या होगी?
0.2.
2t square, or 10 is equal to, when you put 10 is equal to t is equal to 10, which is the initial. So what value will get? 20, right? So this velocity now will be 20, and instead of 0.4 t, what you will put? You will use this equation 2.4, right?
Yes, sir.
Yes, sir.
Okay, so let's look at it. So from time interval 10 to 20 second, I have used this equation again, and for velocity, for acceleration, I put 2.4, and the time interval now it is from 10 to t, or 10 to 20, and the initial velocity was 20, and the final velocity I don't know still. So what equation I get? The equation that I get, it is basically, when I solve it, this equation I get, right? So when you put the value t is equal to 10, t is equal to 10, when you put, you will get the same answer as 20. When you put t is equal to 20 second, so the answer will be 44, right? And you see there is one t, so this is first degree curve, so means this will be a straight line, you can see, and this is at t is equal to 20 second, right?
Yes.
समझ आ रही?
24 कहाँ से आ गया सर?
जी
सर ये 24 2.4 t minus 24, सर ये 24 कहाँ से?
ओके, आप इसको इंटीग्रेट करें ना. इसको जब आप इंटीग्रेट करेंगे 2.4 तो क्या आ जाएगा, 2.4 t आ जाएगा, राइट। लिमिट पुट कर दें t और 10 के, 2.4 t माइनस 2.4 मल्टीप्लाई बाय 10 आ जाएगा ना।
यस सर, सही है।
ठीक है, इज इट क्लियर?
यस सर।
Okay, so now for the third one, now you can see for third one the initial velocity for time range 20 to 30, 20 to 30, what we will be having, basically the initial velocity will be 44 and the final velocity we need to find out, and the time interval will be 10 to 20, not 20 to 20, 20 to 30, right?
Yes, sir.
Okay, so now we will put this time interval, and the velocity will be in this interval and 0. So when you have 0, this one will become 0 and you will get this one. So the velocity between 20 to 30, it will be remain fixed at 30 because acceleration is 0. So when acceleration is 0, this means how much will be the change in velocity?
No
G,
change.
acceleration, no change. So that's why the velocity will remain fixed at 44 throughout, right? Now what we need to find out, we basically need to find out the third one, which is basically the ST plot. So for ST plot, what we need to do basically, we need to have the velocity now. So how we can get velocity? Means if you take its integral, so it will, what we will get if you take integral of 0.4 with respect to time, what will be the answer? T square divided by 2 into 0.4.
Velocity.
So this, so 0.2 t square, right? 0.4 t का आप इंटीग्रल ले ले, क्या आएगा? 0.2 t स्क्वायर आ जाएगा ना।
Yes, sir.
Yes sir.
राइट, ओके। सिमिलरली इसका इंटीग्रल आप ले ले, क्या आ जाएगा? 2.4 t
सर 2.4 t।
ठीक है, ओके। सो ये सारी यहाँ पे हमने बेसिकली इसके वो कर दिए, वैल्यूज यहाँ से हमने नोट कर लिए, बल्कि हमारे पास ये इक्वेशन भी है, डायरेक्ट आप ये इक्वेशन यूज कर सकते हैं। फॉर फर्स्ट वन वी बेसिकली हैव दिस इक्वेशन, for second we have this equation, for third one we have this equation, right, for third time interval. So ये सारी equations हमने arrange कर दी with respective time limits. So now as v is equal to ds by dt, v dt will be equal to ds, right? So ds is basically v dt. So the time limit is 0 to 10 and the velocity in this case initially means from 0 to t is the time limit, the maximum time means t can be up to 10 seconds, and the displacement that we can have, it can be from 0 to s, because why I'm using s naught is equal to 0, it is given in the question, right? And the displacement at t is equal to 10 seconds, I need to find out this one. So when you find it out, what you will get this equation. So at t is equal to 0, the displacement is 0, which is this value. And remember, it's a third degree equation, third degree curve. So it will be like the slope will be having a greater curve. So you can see. Okay. So when you put t is equal to 10 over here, when you put t is equal to 10 over here, so 10 multiplied by 10 is equal to 100 multiplied by 10, it will be equal to 1000. And when you multiply it by 0.067, so the answer will be 66.7 at t is equal to 10 seconds, right?
Yes sir.
Okay, so now between this limit 10 to 20, the initial displacement will be how much? Initial displacement will be 66.7. Initial displacement will be 66.7, and the final displacement is not known, and the time limit will be 10 to 20 seconds. Our initial will be 10 and final will be t, which can be equal to up to 20 seconds. Okay, so this equation, and for this we will put this one. For velocity, instead of velocity we'll put this one. Limit will be 10 to t and displacement will be 66.7 to s. Okay, when you integrate it, you will get this equation. Okay, so when you put s is equal to 0, you will get some, what value you will get? You will get 66.7. And when you put t is equal to
सर
20
इसमें
second,
जीरो सर इसमें जीरो पुट नहीं करना है सर टेंस
sorry, zero put nahi karna, sorry, when the initial time when you put t is equal to 10, sorry, yes, right, we cannot put 0 over here. Okay, I'm mistaken. Okay, so when you put 10 is t is equal to 10 second, so you get 66.7. And when you put t is equal to 20 second, so what you get basically 387. But remember, it's a second degree curve, so iska jo curve aapke paas aayega wo it will be slightly different from this one. It's second degree curve. ठीक है?
यस सर
Now for the third one, the displacement, the initial displacement will be 387. The final displacement we need to find out, and the time limit will be basically this one. Initial time will be 20 and final will be t. Okay, so you can see v dt is equal to ds. Put this one v as 44. When you put it over here, what you will get? You will get this equation, right? So now you need to put t is equal to 20 second. When you put t is equal to 20 second, you will get 387. When you put different value, you will get different sets. This one, this one, this one, this one. And when you put t is equal to 30 second, from here in this equation, you will get 827. Right?
यस सर
Okay. So this is basically when you combine all those equation, you will get this set of equation for displacement, and this is basically the ST plot. So this is the combined answer, like the ST plot, the VT plot, and the AT plot. This is your required answer, right?
यस सर
Okay. Now we have another example, an object travel. You need to do this by yourself. आप इसको खुद कर लें, ठीक है? I left it for you people. Okay, then
Okay.
let's go through a third example. This is from your book, that is R.C. Hibbeler book. Okay. So in this book, so in this example, what we have, the VS graph describing the motion of motorcycle is shown. VS. Where is S? Here we have S. Here we have V. Right? समझ आ रही है ना?
यस सर
Yes, sir.
Okay. Okay. What's else? What's else? Construct AS type, AS graph. So AS, if you recall our previous discussion, so this means what will be involved? Integration or derivation?
Derivation.
Yes.
Derivation.
Calculate the AS graph of motion and determine the time needed for the motorcycle to reach position S is equal to 400 feet. You need to find out the time during which the motorcycle can reach up to 400 S, right? So means from time for displacement interval or from position 0 to 200 feet, which equation will be used? 0.2 S plus 10. And from 200 to 400 feet, which equation will be used? V is equal to 50. Is it clear?
Yes, sir.
Okay. So let's consider the first segment. When the displacement is from 0 to 200 feet, the velocity equation is this one. As we know that acceleration is basically equal to a v dv by ds. Now you know from where this equation came, right? Clear hai na
Yes,
abhi?
sir.
Okay. So for v, we will put its value, and for dv by ds, here for v again we will put its value. So when you solve it, what you will get? You will get 0.04 second plus 2. Not second, it's s, sorry, 0.04 s plus 2, right? So when you put s is equal to 0, you will get 2. When you put s is equal to 0, you will get this value of 2, or what? Acceleration 2
Yes,
आ
sir.
जाएगी ना हमारे पास. Okay, so that's why this is 2. Okay, here. And when you put s is equal to 200, so you will get some other value, and that might be like 10. That's just shown over here, right?
8 I.
8 आएगा. चले
8 +
कैलकुलेट कर
2
लें,
फिर
जो
8
जो भी
+
आपके
2
पास
10
आएगा, ठीक, जो भी आपके, हाँ 10 आएगा आपके पास, ठीक है। ओके, सो नाउ फॉर सेकंड लिमिट दैट इज फ्रॉम 200 to 400, from 200 to 400 we will be having another equation which is v is equal to 50. So this will be 50, and when you take this dv by ds, so derivative of constant will be how much?
0.
So 0 multiplied by anything, acceleration will be 0. So from here onward the acceleration will be 0, right?
Yes, sir.
Okay, now they are basically asking to find out, the time. So first thing is done. What they were asking, construct AS graph, which we did. Now they are asking that the time, we need to find out the time at which it reached this 400. So we need to calculate this time, and then from here we need to calculate this time. So let's do it, the time from here, 0 to 200 feet, and v is equal to this equation. And as we know that velocity is equal to ds by dt. Velocity is equal to ds by dt, right?
Yes, sir.
So dt will be ds by v, and for v we will put this value, right? Take its integral, and the integral will be, means from time t is equal to 0 up till t, and the displacement is from 0 to s. From 0 to s means in this case s will be up to 200. S will be up to 200. Okay, so what you need to do, you need to find out this integral. You know how to find out this integral?
Yes, sir.
J. Okay, it will be by substitution. कैसे करेंगे इसको? Means
Substitute.
you can put, for example, you will imagine like let's x is equal to 0.2 s plus 10, right?
Yes, sir.
Okay, this will be equal to, and then dx will be equal to, you will take its derivative. Is it clear?
नो सर, सर
यार
दूसरा
आपने
मेथड भी है,
मैथ्स
सर
पढ़ी है अभी
दूसरा
फर्स्ट?
मेथड भी है और आसान है.
Okay, okay, whatever method you want to use, but the one that I recommend for this one is substitution. Okay, और if you are having table में अगर आपके पास कोई है तो आप डायरेक्ट वहां से यूज कर लें. But both method, any method, if you use, if you do it properly, you will get this answer. Okay.
Yes, sir.
Okay, so simply it was just to recall you people. Otherwise, like जब कोर्स हम स्टार्ट करते हैं तो उसके लिए जो प्री रिक्विजिट मैथ्स वगैरह के कोर्सेज होते हैं, इसी वजह से फर्स्ट सेकंड सेमेस्टर में आपको रिवाइज कर दिए जाते हैं, एंड इसी वजह से एफएससी में ये डेरिवेशन इंटीग्रेशन पढ़ाई जाती है, ठीक है. बट जस्ट फॉर योर रिवीजन पीपल, इफ यू वांट टू यूज सब्स्टिट्यूशन मेथड और एनी अदर इजी मेथड, इफ यू वांट टू यूज इट, so you can use it. Okay, now from here, when you put s is equal to 200 feet, you will get some time, means, and the time over here it is 8.05 seconds. So means this 8.05 second will be used for the second limit, from for the second range of time from that is when the displacement was 200 to 400 feet. So in second case the initial time will be 8.05 seconds, right?
Yes, sir.
Okay, so at s is equal to 200 feet, t is equal to 8.05 second. So now in second case we are having v is equal to 50 feet. You put values in this equation, ds is equal to, dt is equal to ds by v, and it will become ds by 50. So you need to put values over here. The limits will be from 8.05 up to t, and the distance will be from 200 up to s. Now due to this range. Okay, so when you sort it out, when you find out, you will get this answer. You will get this answer, and the t that you will get, it will be this one, s by 50 plus 4.05. Okay, so therefore at s is equal to 400 feet, means to reach this 400 feet, what you need to do, you need to put s is equal to 400 over here, and the answer will be this one, 12 seconds. So when you solve it, 400 divided by 50 plus 4.05, so you get 12 seconds. So means the time that this biker takes to reach this 400 seconds to 400 feet distance, it is 12 seconds, right?
Yes,
समझ
sir.
आ गई है? Okay. Okay, so the problems given over here, you need to try these problems as your practice problems. ठीक है? It is from R.C. Hibbeler book. Now, curvilinear motion. So, curvilinear motion, as I have told you in my initial class, in our previous class, in our previous week class, that we can have different sort of motion. We can have rectilinear motion, then in rectilinear we can have continuous, and we can have erratic motion. We can have curvilinear motion. Curvilinear motion means when the motion is following a certain path, a certain curve. When the path of motion is along a curve, and we can have circular motion when the motion is along some circular path. Okay, so curvilinear motion, when particle moves along a curved path other than straight line. So we say that the particle is in curvilinear motion. So for example, if you look at this one, like this is following some curve, which I have shown over here. It is not a straight line. So the motion of particle that follows a curved path is basically known as curvilinear motion, right? So curvilinear motion can be analyzed by using Cartesian coordinate system. It can be analyzed by using tangential normal, which is anti-coordinate system, and it can be used by using RT, radial and transverse coordinate system. Okay, so in today's class, what we will do, basically, we will analyze the curvilinear motion by using rectangular coordinates. And that's why this topic is curvilinear motion using rectangular coordinate system, or using rectangular components, or using Cartesian coordinate system or Cartesian components. Okay, so as we have this curve, we have this curvilinear motion. So let's say we are using Cartesian coordinate system or rectangular. So let's draw our x. Let's draw our x, y, and z. Okay. Now to represent any position, for example, this position, to specify the position along this curve, कोई भी position आप specify करना चाहते हैं by using this coordinate. So what you will do, you will try to find out this y distance, and you will find its z distance, and you will also find its x distance from the origin of this position, this path, right? So for example, this is the point. Let's say the coordinates of this point is x, y, z. How we will find it out? So means in z, you need to look at this, that how much it is in z direction from the origin. So this is the z value, how much it is in y direction. So this is basically the y value, and how much it is in x direction, right? So this is basically x, y, z coordinates. This is basically the position, or the distances. The x, y, z are basically represented the distance in x, in y, and z direction from the origin. Okay, to represent the position, we usually use position vector. What we do basically, we use position vector, and position vector is represented, let's say it is represented by r. So we can write it in vector form. Vector here are in 3D space in x, y, z coordinates. So we need to mention all those three variables, that is x, y, and z, all component. So x is along I, y is along j, and z is along k. So if the particle is at point x, y, z on the curved path as shown in the figure, then its location is defined by the position vector, and this is basically the position vector. And remember, this position vector, it is function of time. Means this changes with time. Means, for example, after a certain time, the vector, the particle will be over here, so the position vector will be changed. And then again, after a certain time, it may be over here, so we will be having another position vector. So the position vector also changes with time, right? Whereas x, y, and z, the x, y, z, they are basically components of r, and they are also function of time, because x also depend on time, y also depend on time, and z also depend on time. So in simple words, we can say that r is a function of time, right? G.
Yes, sir.
Okay, so now let's say we have this position, and imagine that after a certain time, the position change from P to P dash, right? Now to represent this position, so we must have another, we will be having another position vector, that is this one. And the difference between final position and initial position will be equal to
Displacement.
G, displacement. Very good. So the difference between final position and initial position, or the difference between these two position vector, will basically gives us displacement vector, right?
Yes, sir.
Okay, and that displacement vector is basically represented by delta R. So delta R is basically R bar minus R, this final position minus initial position. Okay, so imagine if the time interval is very short. So in that case, this basically displacement, it can be represented by dr, right? And if the time interval is very short, very short, so this means that the distance or the path between these 2 points, it can be almost a straight line, right? हमारे पास जो कर्व होता है, it is combination of so many straight lines जो कि हर एक पॉइंट पे डायरेक्शन चेंज कर रहे होते हैं, right? For example, we are having this curve, so it is combination of straight line, then another straight line which changes direction, then another straight line changes direction. Is it clear? So if we consider a very small time, a differential time, so mean that the distance between these 2 points, the difference between these 2 points, or the path that we have between these 2 points, it will be a straight line. Or in other words, the displacement in this case, it will be perpendicular to the position vector. Both will be perpendicular now, if we take a very small time, right? Okay, so now the change in displacement, or the differential change in the position with respect to the time, or in a given time instant, or in that very small instant, it will basically gives us the instantaneous velocity. It will gives us what? The instantaneous velocity. So when time t approaches to 0, so this one will become dr by dt, right? So this means if this distance is almost straight, so this means the path that the particle follows from moving from this point till this point, this means that will be tangent, this delta r or this dr, it will be basically tangent to this path. And you already know what is tangent, right? For example, if you are having a circle, and if line is touching this one at a point, so that will be tangent. Okay, so note that if delta t is very small, then our r bar and r are almost fall on the same line, and this very small dr is perpendicular to the position vectors, and therefore tangent to the path. So here we can derive an important conclusion that direction of instantaneous velocity is always tangent to the curved path, right? Means this, the direction of instantaneous velocity means which is during a very short time, that will be basically tangent to the curved path that it follows. Okay, now for velocity, we have dr by dt, and dr is a function, means it is further, it can be written in form of its components, which is xi plus yj plus zk. If you recall this one, so this means if you recall, or if you put r as a value and take its derivative with respect to time, so we will get dx by dt I, dy by dt j, dz by dt k. So means we can write this one dx by dt as x dot. X dot means first time derivative, and similarly y dot j and z dot k. And we can also write this velocity in vector form as vxi, vyj, and vz k. Okay, and if you want to find out its magnitude, so it can be vx square plus vy square plus vz square and whole square root. So from here we can find out the velocity. Okay, for acceleration, what we need to do, we need to take derivative of velocity. So velocity is equal to basically derivative of displacement. So for acceleration, we need to take double derivative of displacement. So d square r by dt square. And again, if you write this r in terms of its component, so what we will get basically dr d square rx by dt square, and over here we will be having d square ry by dt square, and over here d square rz by dt square. So here instead of double derivative, we have put the velocity vx, vy, vz. That's why it's first derivative. So vx is already equal to uh, x dot i, x dot I. So when you take another derivative, it will be double derivative. So acceleration in component form, it will be x double derivative I, y double derivative j, and z double derivative k. And if you want to write down it's in vector form, so it will be a is equal to axi plus ayj and azk. If you want to find out its magnitude, so take the component, take out take their squares, add them, and take the square root of whole. Okay, the acceleration of particle, as we know, it can be obtained by derivative of v. So I have mentioned over here. The direction of acceleration, it will neither be perpendicular nor tangent to the path. It can be in between. Okay, so let's take an example on a curvilinear motion. An object travels from origin along a curved path as shown. So this is the curved path with object following. If its horizontal velocity vx is at, means it is having velocity in both direction, right? This is x, and we also have its y component. Means the velocity is like this, right? समझ आ रही है?
Yes, sir.
Okay, so उसका जो x component है velocity का वो given है. Vx is equal to 8t meter per second, where t is in second. Determine the magnitude of its velocity, acceleration, and distance from origin at t is equal to 2 seconds. From origin to t is equal to 2 seconds. So we don't have the y component of velocity, but at least we have some relationship between y and x, which is given with help of this diagram. Okay, so vx, we know that vx is basically dx by dt. We can write vx as dx by dt, right? Can we write it?
Yes, sir.
Okay.
Yes, sir.
So that is given as 80. So if you want to find out the value of x, so what you need to do? Integral लेंगे ना?
Yes, sir.
Yes, sir.
Okay. So when you take the integral, so what we will get, x is equal to 4t square. Okay. So we have x value and we have y equation. So for y we have this equation. If you put x value over here, we will get the y value. So in this equation, when you put this x value, we will get 2t cube, right? Okay. So what basically want to find out? You want to find out distance, acceleration, and velocity. Okay. So we now have x value. We now have y value. Put it over here. Put it over here. So we get this position vector, right? Take its derivative with respect to time. We get this velocity vector. Again, its derivative with respect to time. So we get this acceleration, right?
Yes, sir.
Okay. So now what they are asking, what we need to find out? We need to find out distance, acceleration, and velocity at t is equal to 2 seconds, right? So what we can do?
Yes, sir.
What we can do, we can put t is equal to 2 seconds over here. So when you put t is equal to 2 seconds over here, you will get r this one, v this one, and a this one. So this is in vector form. If you want to find out the magnitude, so how we can find out magnitude? X component ka square plus y component ka square and square root. You can get magnitude of distance you can get, or the position vector which will give you the distance. We can find the magnitude of velocity, we can find out the magnitude of acceleration, right? समझ आई इस चीज की?
Yes, sir.
Okay.
sir.
Now let's take an example from your book, RC Hebler book. Okay. I think ये एग्जांपल खुद कर लें, चलें, ठीक है, गिवन है, बस आप उसको कर लें.
Yes, sir.
ये भी बस कर लें, ये दोनों ट्राई कर लें, अगर कोई मसला हो फिर मुझसे डिस्कस कर लें. ओके
Okay.
ओके, सो ये दो एग्जांपल्स आप खुद कर लें, एक मैंने करवा दिए हैं, ये दोनों सॉल्व्ड है. इफ यू हैव एनी प्रॉब्लम इन दिस वन सो वी कैन डिस्कस इट. ठीक है, इसमें कोई इस तरह की मुश्किल चीज नहीं है. इक्वेशन वगैरह उसी तरह का गिवन है, कुछ कंपोनेंट्स गिवन है, एंड यू नीड टू फाइंड आउट द रिक्वायर्ड थिंग्स. सो इट्स वेरी मच इजी. लेट मी नो कि अगर आपको कोई मसला हो तो मैं फिर अगली क्लास में डिस्कस कर लूंगा. ओके, I have also uploaded previous lecture videos in Google Classroom, and there is one small correction which I have mentioned. वो आपने देखा था वो correction? Okay, remind me at the end of class ताकि वो correction मैं आपको बता दूं. Last time actually when we were finding in example 2/9 the slope of curve, instead of slope of curve हमने जो values ली थी वो diagram की ली थी, x axis और y axis की दी थी. Exactly curve के ऊपर हमने नहीं ली थी slope की values. ठीक है, उस वक्त मेरा ध्यान नहीं गया था, लेकिन बाद में मुझे एक स्टूडेंट ने रियलाइज करवाया. सो दैट्स व्हाई आई हैव मेंशन्ड ओवर देयर दैट यू नीड टू बी केयरफुल. सो you check that example, sorry, problem 2/9 of JL Mariam book, dynamics portion, and then tell me कि वो आपने सही कर लिया या नहीं किया. अगर if you want discussion on it so we can discuss them. Okay, so in curvilinear motion, the second part that we have basically it's projectile motion, and again we are continuing with particle kinematics. So it's project motion of a projectile. Now what is projectile? So projectile, we can say it is an object or a body or a particle which is thrown at a certain angle with some initial velocity. So definitely if it is thrown at certain angle, if it is not horizontal, then it will follow that path, and the only force that the projectile experience during its flight, that is basically the acceleration due to gravity, the force which act on it due to gravitational force. So it can be, you can say it is same as like the free falling bodies, but in this case we are having some initial excitation, some initial force, and we throw the object at certain initial velocity. For example, this person over here, he take the ball and he throw it with some initial velocity and at a certain angle, right? So what we imagine over here, that the air resistance or the other resistance which is basically stopping this motion, it is neglected. The only resistance or the only force which affect this motion, that is basically the gravitational force or the acceleration due to gravity. Means the change in velocity is due to this force. It's due to the gravitational force. So as the ball is basically moving upward, it's following this path, but due to this gravitation, it basically pull this ball downward, and its path then change, and then suddenly it start moving downward. So based on this, we can define a projectile is an object which is thrown at an angle with a certain initial velocity, and upon which the only force acting is gravity. So by definition, a projectile has a single force that acts upon it, that is the force of gravity. So if there were any other force acting upon an object, then that object would not be a projectile. So the simplification that we have, that there is only one force acting on this motion, or the resistive force acting, that is due to gravity. Okay, thus the free body diagram of a projectile would show a single force acting downward and labeled as force of gravity, or simply F gravity, which is this one. The force of gravity, that is basically downward, right? Okay, so projectile motion, which is a form of motion in which an object or particle, which is basically called as projectile, is thrown near Earth's surface. Why near Earth's surface? Due to that G. If it is not near Earth's surface, if it is out of gravitational field, so and if there is no force which attracted towards the surface, it will follow the same path with which it is hit. So that's why the word is used over here. Form of motion in which an object or particle is thrown near a surface and it moves along a curved path under the action of gravity only. The implication here is that air resistance is negligible. Okay, so and we neglected that air resistance in our equation. The only force of significance that acts on the object is gravity, which acts downwards and cause that downward acceleration. Because of the object inertial, no external horizontal force is needed to maintain the horizontal velocity. So means due to its own inertia, due to its weight and the initial excitation, it is basically maintaining that horizontal velocity. So this is basically the projectile motion as shown over here. Okay. So the motion, how we can analyze the motion of projectile? So the free flight motion of projectile is often studied in terms of its rectangular components. To illustrate the kinematic analysis means we will not consider the force, the initial force which causes the motion. Consider a projectile launched at point x naught, y naught, means from this point. This is the projectile motion. This is the projectile motion. So this point, let's say it is launched at this position x naught, y naught with initial velocity v naught. The initial velocity is basically v naught, having component v naught x and v naught y. So definitely ये inclined है, so इसके दो components आपके पास होंगे. One will be v naught x, other one will be v naught y, as shown in this figure. When air resistance is neglected, the only force acting on the projectile is its weight, and weight is due to gravitational attraction. It's the pull with which attracts the body, which causes the projectile to have a constant downward acceleration of approximately 9.81 meter per second square. So this is the only force, external force which is acting. So after a certain time t, it reaches another position. Let's say it is position that is having coordinate x and y, and the velocity that it have at this instant, let it be v. And again, it's following that curve path, so it can have vx component and it can have vy component. Okay, so again the same diagram is represented by this xy plot. So this is the initial position, this is the final position, for example. So initial position is having x naught, y naught. So this is x naught value, this is y naught. The final position, it is having position y, this is the y, and this total is basically x till this point. And the only force are the change in velocity, which causes changing velocity, that is gravitational force. Okay, so as there is only constant acceleration g in negative y direction and no acceleration in the x direction, and there is no acceleration in the x direction because there is no force which is changing the motion x direction. There is only one force which is causing the acceleration in y direction. So we can apply the equation of motion with constant acceleration. So equation of motion with constant acceleration, they are basically given over here. S is equal to s naught plus v naught plus half at square, v is equal to v naught plus at, and v square is equal to v naught square plus 2a into displacement. So we can use this equation. Okay. So if you want to apply these equation on the horizontal portion, okay, remember that the projectile motion will be having in projectile motion, we are having motion in x as well as in y direction. We are having a simultaneous x direction motion as well as in y direction, right? दोनों डायरेक्शन में मोशंस होगी ना हमारे पास.
यस सर, 2 डायमेंशन मूवमेंट.
ठीक है. ओके, सो इन एक्स डायरेक्शन हमारे पास एक्सेलरेशन कितनी है?
0.
जी कितनी है?
0 है सर।
0 है. So means if I want to find out, for example, this if I want to find out the final position in x, if this is x1, this is x0, right? This one will be the initial velocity. This one will become vx, v0 xt, right? v0 xt, and over here acceleration is 0, so this term will be removed. If the initial time is 0, so this term will also be removed, right?
Yes sir.
Okay. But if it is having some value, so then this term cannot be removed. So we can use these equation for x and y. So let's say for horizontal motion, acceleration x is equal to constant, and this is basically equal to 0. And in y direction, the acceleration that we have, that is basically equal to minus g. So the equation that we can have, which I just discussed, the final position in x, it can be given from this one. If this, instead of this one, if I put x, for this, if I put x0, so we will get this equation, right? Okay, over here this is not t0, I have mistaken, this is t. आपने भी मुझे नहीं बताया, this is t, not t0. Okay, and the vx is equal to v0 x. ये कैसे है आपके पास? This equation. If you put this acceleration as 0, so vx is basically equal to v0 x square. So means the x component of velocity over here and the x component of velocity over here, it will be same. Okay. And vertical, in vertical, what we'll be having? This one will become y. If the position is y, this one will become y0. This one will become v0 yt, and this one will become half gt square and with minus sign. So this will be the equation. Are you getting me? समझ आ रही है?
सर ये आपका कर्सर सही नजर ही नहीं आता सर बीच में.
Okay, cursor सही नजर नहीं आता. Okay, now you can see this one. If instead of s, if I put y, if instead of s0, if I put y0, instead of v0, since I am dealing with y component, so this would be v0 y, right? And t will remain as it is. 1/2 will remain as it is. Acceleration will remain as it is. Instead of acceleration, we will put minus g, and t will remain as it is in y direction. So when we do it, what we will get? We'll get this equation.
Yes sir.
Okay. And for y, means if you want to find out the final velocity in y direction, so we will get this equation.
सर
G.
सर हमने ये माइनस साइन क्यों पुट किया जी के साथ?
Downward act.
This acceleration due to gravity is downward, right? And we always, in our normal convention, we usually think means consider thing positive when they are upward, right? So we always consider acceleration due to gravity as negative.
सर लेकिन प्रोजेक्टाइल मोशन में वो फिर वो जो ऑब्जेक्ट है वो नीचे भी तो आता है, फिर वो पॉजिटिव जी में नहीं होगा हाफ?
No, yeah, okay, you can look at this one. When it started its motion, so the acceleration is downward, right? The acceleration is downward, means the velocity is basically decreasing. And over here again, when its velocity increases, so again it is towards downward. So in both cases, the acceleration is downward. In this case, the acceleration is downward. In this case, since the motion is upward, that's why velocity is decreasing. Over here again, the acceleration is downward, but the motion is also downward. That's why the velocity is increasing. Means you look, in this case, the motion is upward, whereas acceleration is downward. So that's why the velocity is decreasing. And in this case, the velocity or the motion is downward and the acceleration is also downward. So that's why there is increase in the velocity, right? But if you find out in both of the cases, you will get value of g or value of acceleration downward, right? So in this case, we will get negative sign. and in this case we will get positive sign. जी clear हुआ?
Yes, sir.
Okay. So remember that the horizontal motion and the vertical motion both takes place simultaneously. Means it takes place at same time. ये नहीं है कि horizontal motion पहले हो जाता है फिर उसके बाद vertical motion होती है. Okay, so this is one of the example with just to verify कि अगर आपके पास ये horizontal motion हो, ठीक है, तो effect of gravity पे उसका कोई असर पड़ेगा या नहीं पड़ेगा. So in this case, what they did, they let the ball move downward, the red ball, they let the ball move downward, I mean in a straight path, and then in second case they give it some excitation in the x direction, right? And what they did, they basically provided a controlled environment in which there was no air resistance, and the only force which was acting on these balls, that was basically that acceleration due to gravity, due to which the velocity or change in velocity takes place. So then they explain this experiment that each picture in this sequence is taken after the same time interval. The red ball falls from rest, whereas the yellow ball is given a horizontal velocity when released. Both balls accelerate downward at the same rate, so they remain at the same elevation at any instant. This acceleration causes the difference in elevation between the balls to increase between successive photos. Also note down the horizontal distance between successive photos of the yellow ball is constant, since the velocity in horizontal direction remains constant. So इन सारी चीजों को कहने का मतलब ये है कि आपके पास जो acceleration है, the only force which is basically causing the motion, which is basically causing change in velocity, that is the acceleration due to gravity. ठीक है? So अगर आपके पास air resistance वगैरह आप neglect कर दें, so आपके पास जो x velocity है, in instantaneous में अगर आप देख ले change in velocity in x direction, वो that will be zero, because there is no force which is changing the, so means the x velocity over here and the x velocity over here will be the same, and the change in velocity in y direction between these 2 points and these 2 points, it is same. The change in velocity between this and this, it is same. So what they want to say, what they want to conclude, basically the things that they have explained in the previous slides, कि आपके पास जो acceleration है, it will act only in the y direction. That means x direction में आपके पास कोई acceleration नहीं होगी. So for that purpose, they have performed that experiment in a controlled environment, and just to verify that thing. Okay, so these are the equation which we basically get. These are the constant acceleration equation of motions, and from here for horizontal motion we get this equation, and for vertical motion basically we get these equations. Okay, so now let's have an example from your book. आपके बुक से एक एग्जाम्पल कंसिडर कर लेते हैं. A sag slides off the ramp. What is slack? What is sag? This is basically that inclined surface. You can say it's some surface, some floor, earth surface, or some level. I have also mentioned this thing over here, that it is basically a roadway that is connecting different levels. For example, this level, or this level, right? Means it is connecting different level, but it is inclined. For example, from this to this, it is inclined. Again, from this to this, it's inclined. So throughout, it is inclined. So a sag slides off the ramp shown in figure 1221 with a horizontal velocity of 12 meter per second. If the height of ramp is 6 meter from the floor, what you need to determine the time needed for the sag to strike the floor. Means from this one to this one, floor is at B. You need to find out the time from A to B. So TAB is needed. And the range are where the sag begins to pile up. And you need to find out the distance that it covers in the x direction, R. Right? Okay. So what is given initially? Of the ramp shown in figure with the horizontal velocity of 12 meter per second. So initially, the horizontal velocity that we have in this case, you see, at this point, the horizontal velocity is basically 12 meter per second. and the vertical velocity at this instant, it is 0. From here, it slides off, and the only force which we have in projectile motion that it observes, it is basically due to gravity. So gravity in this case, it is minus 9.81 meter per second square. So the velocity over here in y direction, we don't know about the y direction, but for x direction, at least we have identified that the x velocity over here and the x velocity over here will be constant. We did it from the equation. We proved that thing from the equation as well as from the experiment. So generally, without using equation, I can put it down like this way, that vbx, the x component of velocity over here, and x component, it will be the same. What we need to do, basically, we need to find out this x distance, this distance x r, and the time from A to B, which is TAB. Okay. So what we can do, basically, some explanation has been given over here. The origin of coordinate is established. So let's say this is the x, this is the y. Okay. So this means the initial position in x and y both are basically 0. The starting position in starting, we have x is equal to 0 and y also equal to 0. So means what we need to do, we need to find out xb. If we find out xb, so this r will be automatically identified. So the origin of coordinate is established at the beginning of path at point A, as shown in the figure. The initial velocity vax is equal to 12 meter per second and vay is equal to 0. Also between A and B, the acceleration is ay, which is minus 9.81, whereas vbx is equal to vax, which we just explained. And the three unknowns, what are the unknowns? vby, r, and tb. So here we may not need that vby. So let's look into the example. Okay, we have vx, we have vy, we have this thing, and we have this one. This is basically the given data, and this is TAB. So this is for horizontal motion, and this is for vertical motion, right? So what they are asking for? They are asking for the time. They are asking for the time. So where we can find out that time? So if we use this equation, for example, we have x naught, but we don't have x and we don't have t. Okay, if you look at this one, we have this value y naught, which is 0. We have final y. How much is y? Y कितना हमारे पास? जी Hilal, Netra. Okay, will it be positive or negative? Ji Hilal. It will be negative because this is the origin and y is upward positive, so it will be minus 6. Okay, do we have v naught y? Yes, we have v naught y, which is 0. Okay, do we have g? Yes, we have g. So from here we can find out t, right? The final time from A to B. So by using this equation, when you put all those values, what we can get this TAB. And now what they are asking for, they are asking for the final position in x direction, the r, the final position in x direction. So if this is xb and if this one is xa and this one is v naught x, so this is given, and t is also given now. So we can find out this xp. So xb is basically equal to xr. So put values in this equation and you can find it out, right? समझ आई इस चीज की?
Yes, sir.
ओके ओके, ये खुद कर लें, काइंडली इसको आप खुद देख लें, ठीक है? So it's easy, it's not that difficult. सारा डेटा वगैरह इसमें गिवन है. Okay, let's check this one. Okay, give me a minute. Okay, can you hear me? आवाज आ रही है आप लोगों को?
Yes, sir.
Okay, so let's have another example. The path of projectile is shown. So this is basically a projectile path, this one, right? Okay, pardon me, ये मैं जो लाइंस वगैरह लगा रहा हूँ माउस से लगा रहा हूँ, so उससे आपको पता है ज्यादा क्लियर नहीं आती, ठीक है? If the object has initial velocity v naught is equal to 30 meter per second, that is perpendicular to the slope. That is perpendicular to the slope. This one, slope up. Okay, determine D. What we need to do, we need to find out D. And the only force which it observed are the resistive force, that is basically acceleration due to gravity. That is acceleration due to gravity, which is downward force, right? So what we need to do, we need to basically find out this T. Okay, so acceleration is downward. If we put our x, let's first select the coordinates. So let this one is x-axis and this one is y-axis, and this is the origin, right? So the velocity that we have over here, it is perpendicular to this one, to this surface. It is perpendicular to the surface that is making an angle of 30 degrees. Okay, if the angle between this surface and the horizontal is 30, so this means the angle between the perpendicular surfaces, which is this one and this one, should be how much? Angle कितना होना चाहिए ये?
60 degree.
60?
कौन सा सर? कौन सा सर?
ये जो मैंने भी यहाँ पे ड्रॉ किया. Remember the angle between perpendicular
45.
arms.
45.
The angle between perpendicular arms are always equal, right? Okay, so this is horizontal and this is a line. This is line and this is horizontal. So if I draw perpendicular to this one and if I draw perpendicular to this one, so what will be the angle over here?
30.
30. So what should be the angle here now?
30.
30.
Very good. ठीक है. Okay, so Vx will be, V naught x will be 30, sine of 30, right? And angle इस side पे है, so V naught y will be V naught cos of 30, right? Clear है यहाँ तक? So ये values मैंने identify कर. Okay, now imagine this one is making, and this one is basically making a right angle triangle. ठीक है? So this, if this is 30, this can be d cos of 30 and this can be d sine of 30 if this distance is d, right? समझ आ रही है?
Yes, sir.
Okay, but okay, this one is in positive direction, so this is positive, and this one is in negative y direction, that's why this one is with negative sign. Okay, so we did this, and the only force that it observed basically in downward direction, that is force due to gravity. The acceleration, the only acceleration we have, that is acceleration due to gravity. Now, so what we need to basically find out, we need to find out this value of d. We need to find out this d value. In other words, we need to find out the initial position. If the initial position, if x is 0 and the y is 0, so what we basically want to find out, we need to find out the we need to find out the value of x and y. What we need to find out, we need to find out the value of x1 y1. If this is x0 y0, which is 0 0, we need to find out this position. So how we can find out this position? If we get this x value and y value, so we can identify. Even if we only get this x value, still we can find it out by using this equation, right? So from equation of projectile for x direction, x is equal to x0 plus v0 xt. right? So x is equal to, this x naught is 0, this x naught is 0, and for x is equal to how much? X is equal to d cos 30 from here. This is the x distance which it covers from here till this point, right? Which is given by this d cos 30. So x is equal to d cos 30. आवाज आ रही है आप लोगों को?
Yes, sir.
Okay.
Yes, sir.
Okay. And v naught x is equal to v naught x is given by 15. So this is equal to 15t. Now let's apply the same equation on y direction. So y is basically equal to y naught plus v naught yt minus half gt square. This y naught is 0. Initially y naught is 0, and this v naught y is how much? 26, right? And t let it be like this, and g is minus 9.81. So when you put it, this sign will become minus. Initially it was positive. Okay, and this y is equal to minus d sine 30. Okay, so when you put, you get this equation. So now we are having two equations. This d cos 30 degrees equal to 15t. So what you can do, you can find out value of d from this one. D is equal to 15t divided by cos 30. Put it over here. Put the value of d here. Eliminate d from here and put that value here. So what you will get? You will get this t. So from here you can get this t value. When you get this t, put that t value over here and you will get d value, right? क्लियर हुआ आपको?
Yes, sir.
Okay, sometime हम क्या करते हैं, we what we can do, we can use alternate coordinate system. Means instead of using xy coordinate like this, what we can do basically, I can put this y coordinates like this and x like this. So this will make things simpler. But remember, then in that case the g will become inclined. The g will be inclined. For example, let's see this one. I arrange diagram for my ease, for my comfort. So this is x, this is y. But remember, now the horizontal surface or the earth surface, it is now at certain angle. And what is that angle? It is 30, right? समझ आ रही है?
Yes, sir.
जी सर.
Okay, but this g, it is towards, or it is perpendicular to this surface. This g is perpendicular to this surface, right? So g can have two components, ax and ay. So if this angle is 30 degree, then the angle between perpendicular and vertical, this will also be 30 degree. Angle between perpendicular arm, right? I mean, this is the angle between this one and horizontal. So the angle between perpendicular and vertical, it will also be 30, right? समझ आ रही है?
सर पर ए एक 0 नहीं होता सर, आपने पहले कहा था.
वो मैंने कहा था, लेकिन ये आप देखें कि ये प्रोजेक्टाइल मोशन को मैंने क्या कर दिया, मैंने तो पूरे डायग्राम को रोटेट कर दिया. डायग्राम तो आपके पास ऐसे था ना, ठीक है?
ठीक.
So now when you have changed the whole rotation, now you see, आपने अपने आसानी के लिए जमीन को ही इंक्लाइन कर दिया पूरा, right?
ठीक.
So now in that case, so now what we have now over here, you can see that the velocity that we have, it is having only y component, no x component. Initial velocity.
Yes sir.
Okay, so what you can do, So in y direction now, the final position, the initial position in y direction is 0. The final position in y, it is 0. So when you use this equation, the initial position in y is 0, the final position in y is 0, the initial velocity in y direction, which is 30, whole will be in y direction, right? And the acceleration y component, this component will be used, right? Y direction component. And from this single equation you can identify this t. And for x direction, what you can do, again the same equation can be used for x direction. So initially x is 0, so this will be eliminated. The initial velocity in x direction, this one is 0, and the value of acceleration in x direction, this is given by this one. Time is also given over here, so you can find out this final position, which is rd, right? So this is the same problem. What you can do means, आप क्या कर सकते हैं, इस प्रॉब्लम को ऐसे ही रहने दें, अपने xy को नॉर्मल कन्वेंशन के मुताबिक होगा दें, लेकिन इस केस में ये प्रोजेक्टाइल मोशन क्या होगा, इंक्लाइंड होगा. आप क्या कर सकते हैं, इस y को यहां पे कर दें, x को यहां पे कर दें. सो प्रोजेक्टाइल एनालिसिस आपके पास आसान हो जाएगी, लेकिन g जो होगा वो इंक्लाइन हो जाएगा. तो आपने g को क्या करना होगा, या एक्सेलरेशन ड्यू टू ग्रेविटी, उसको सिर्फ रिजॉल्व करना होगा इन दिस केस. So I have mentioned this thing over here. Alternatively, you can set your coordinate axis this way as shown and can solve the problem. But in this case, the horizontal Earth surface become inclined. So G will also be inclined and will have components. Right? जी समझ आई या नहीं आई? Clear है? Okay, I'm not receiving any response, so this means clear.
Yes, sir. Clear.
Okay. Okay, so these are the problems. You need to go through these problems. ये problems भी देख लें, और इसके साथ जो और relevant problems है वो भी kindly आप check कर लें. If you feel any problem in examples में, if you find any problem, if you have any difficulty, पहले खुद try कर लें, then let me know. अगर discuss करने की जरूरत हुई तो discuss कर लेंगे. Otherwise, I will provide you with the solution for any specific problem that you want. ठीक है? And you can search it out on internet. Maybe you can find the solution manual also. Okay.
Sir.
So this is basically ends of today's class. If you are having any question regarding today's class, you can ask. If you don't have question, then let me know so that I can turn off the recording. Okay, no question. Okay, did you get the correction that I have just discussed for the previous class? जो एग्जाम्पल 2.9 था, उसमें जो स्लोप हमने फाइंड आउट किया था, वो डायग्राम वो हमने गलत किया था. एक्चुअली हमने कर्व के ऊपर स्लोप लेना होता है.
सर स्क्रीन शेयर करके बता दें.
स्क्रीन शेयर करके बता दूं? ओके. Okay, so now I think you can see my screen, right?
Yes.
Yes, sir.
Yes, sir, we can see
Okay.
you.
Okay, so over here, when I was trying to find out the slope, what I did, I select these two, the distance between these two instances, and this one, right? But the curve is not here. The point on curve is not at this location, right? So what we need to do, if you want to find out the slope of this point, So of this line, so you need to select any point on this curve. For example, this point, and you need to take this value on the x-axis, and you need to take the value on the y-axis, right? So if you want to find out the slope of this point, you need to select y as 2 and x as 17.5, right? If you want to find out slope of this line, so you can take x as 4 and y as 22.5, right? अगर आप इस
Yes,
पॉइंट का
sir.
स्लोप फाइंड आउट करना
Yes,
चाहते
sir.
हैं, so y will be 3 and x will be 20, right? So slope is basically for this curve. लास्ट टाइम एक्चुअली मैंने आपको क्या बताया था कि आप y में ये 2 ले लें किसी भी दो के दरमियान, और x में भी किसी के दो के दरमियान डिस्टेंस ले लें. तो एक्चुअली वो उस केस में है कि अगर आपके पास ये जो कर्व है यहाँ पे, ये बिल्कुल स्ट्रेट फ्रॉम दिस एंड टिल दिस एंड, ये आपके पास बिल्कुल स्ट्रेट आ जाए, which is not the case here, right? So
Yes, sir.
at s for the slope of this curve, you can use the method which I just mentioned.
Yes,
Okay,
sir.
I hope कि आपको भी क्लियर हो गया होगा. So मैं रिकॉर्डिंग ऑफ कर देता हूँ. ऑफ कर दूं रिकॉर्डिंग?
Yes, sir.
Yes, sir.